Hello everyone, this is video number 8. We're going to be talking about operators in Python today. In the last video we talked about variables, and before that data types, which we use to store data in memory. Now, storing data in memory is useful, but if we can ever change that data, well, that's not very useful. So we need operators to operate on that data, which can be a whole lot of things. We're going to go through just the comprehensive list of Python operators. We will not be using all of these operators, and many of these operators we're not going to be using for a while. We won't use until the second half of the semester. That being said, we're just going to go through this big list now, and then we'll be practicing mainly with the arithmetic and assignment operators after this. We will have a video on that. We will have a video practicing and using the conditional and Boolean operators, and then everything else after that, for the most part, will be used much later on, and we'll tackle those operators when we get to later topics, such as when we're talking about data structures, when we are talking about objects and inheritance and things like that. So we're going to start with the definition. What is an operator? Well, basically these are symbols. Every single punctuation on your keyboard is there because of programming. This is true for any language. All these different symbols are originally needed for programming, not actually typing, because programming in some ways preceded the need for writing a Word document or whatever, since programming started very early on, even as early as the 1800s. If you're talking about mechanical computers, if you're talking about electronic computers, we're talking about the 1940s and onward, where we first had electromechanical computers. The arithmetic operators, we're going to know some of these. We're going to jump right into those. We'll make one row per symbol operator. Some of these operators are going to be more than one characters, so we'll get to those in a second. But first we've got our main for, which we're going to know right from the get-go. We're not going to have to talk too much about these. Let's see, let's get some good spacing here. Oops. We have addition, or the addition operator. Not much more needs to be said. We can add things together, add different values in variables or for the actual literal values. We have subtraction. And this one might not be immediately obvious, but this is going to be the symbol we use for multiplication. And this last symbol is division. All of these are going to work just how you think they would from your math class. And then we're going to get into some operators maybe you've not seen before or used before that will do some practice. First, very similar to division, is something called integer division. So we'll do some examples for this. If we take a value such as 1 divided by 2, when you're doing normal division, such as when we're using this symbol, a single slash. This slash, by the way, is the same key that is shared with the question mark. So we call this the backslash, which you're probably more used to using. We'll also be using the forward slash sometimes this semester, which is the key usually above the enter key or next to it that shares another symbol which you've probably not used before, which is called the pipe, this straight up and down line. So with normal division, we know that 1 divided by 2 is really the same in decimal form as 0.5. So when we're doing normal division, we get what we'd expect. For integer division, it's a little bit different. We're going to get a value of 0. Why is that? Well, for integer division, the rule is whatever our result is has to be a whole number. The second rule is that we're not doing any rounding when we do integer division. So if we get a result of 3.99 for integer division, if that would be what the decimal would be, we are just cutting off all those decimals. So to remember how to use this, we remember a few things. One, the result will be a whole number no matter what. And the second thing to remember is we chop off any decimals, no rounding. So let's do another example. If we have something like 9/10, well, this is going to be a value that you typically think of rounding, perhaps. It would normally be 0.9, very close to 1, but in Python programming, we don't care if we're doing integer division. And I've been using the wrong symbol. This should be the double slash. There we go. Make sure you have that. The double slash here is integer division. Single slash is regular division. 9 divided by 10 in integer division, also 0. Let's get a value that's greater than 0, like something like 2 point something. How about 7 divided by, maybe we should do something bigger. How about 25 divided by 8? Yeah. So 25 divided by 8. Oh wait, no, we want the opposite. We want to do something like 7. Would 6 be? No. It doesn't really matter. Let's just do 25 divided by 7. This is going to be something like 3 point something. It'll be slightly more than 3.5. Let's see what that value is. If we take 25 divided by 7, 3.57. So we're going to round this to 3. I was trying to get a number that was like 3.99, but I don't want to think too much about it. So whatever the case, we cut off our decimals with integer division. This is going to be really useful because sometimes we just want a whole number. If you have something that should not be divided, then you probably want to just use whole numbers, and this forces that. This is also going to be really useful when you are trying to compute things like how many whole number values fit into something larger. Like if we divide if we're thinking about how many dollars fit into a certain amount of change or some kind of cost, or how many quarters fit into a certain value, we'll probably want to use some form of integer division. And something else that is very useful is this operator called modulus, also called mod, and this is also known as the remainder operator. Modulus is actually something that you probably have done a long time ago. If you ever did a long division in elementary school, there was a type of long division that you might have done where you would get a number, and if it didn't go in evenly, instead of finding the decimal value, you might have just written the letter R and gotten the whole number left over. For instance, if we take 20 and divide it by 6, well, 6 goes into 18, right? That's the closest multiple. That doesn't become greater than 20, but we have 2 left over. So either you could get 6 point something, 6.3333, or you could write that as 6 with a remainder of 2. There's 2 left over. So this is how modulus works. If we take that example, 20 mod 6, we don't get 3.333, we get just 2. So this gives the remainder. If we had something that divides evenly, well, then our remainder is 0. 5 goes into 20 perfectly, there's nothing left over. We could also have an example where you have something that only goes in once. 20 mod 17 is, well, it goes into it once, so we have 3 left over. What about if the first number is less than the second number? How many times Well, what's the remainder after you divide 4 by 7? Well, 7 doesn't go into 4 at all. So our remainder is just going to be what the original number was, which is 4, whatever's left of the number. And that's true for any case. If we have anything less than that, 4 mod 107, that's 4. If we have 16 mod 17, that's 16. And so on. What other situations can we have? We could have something like 0. 0 is a weird one, but it's going to work the same way as the last 3 examples. 6 is not going to 0 at all, so the remainder is just the original number, which is 0. However, if we flip the switch here, if we do the opposite, we are basically saying, what's the remainder after we divide 6 by 0? But that's the problem. If we divide 6 by 0, we know that's an issue in math. We say that that is undefined or infinity, or there's a few other words for describing it. But basically we can't do it. Same thing with Python. If we try to do 6 mod 0, we will get an actual error. And in fact, it'll be a 0 division error, I believe. So let's see this in action. Let's try and do it. So we can make some kind of variable. We'll call it box, and we'll put 6 mod 0. And why don't we just print that to the console? See what happens. And we do get an error. Anytime we see red, that shows up in this run box here. That means that we do have an error, and it is called a 0 division error. And it points out we cannot do integer modulo. We're talking about modulus by 0. So, no can do. There are other examples that we might want to look at, or that you might want to look at, other possibilities that it operates a little bit, not different, but ways that are good to understand and practice for negative numbers. However, using negative numbers with modulus doesn't appear on the AP test, and frankly, it doesn't appear in programming much either in practical uses. So we're going to not go over those examples, but know that it is possible to do modulus with negative numbers. All right, so that is modulus. You may want to refer back to these examples, write some notes on why you get these results, because it is a new type of mathematics, kind of. It's something you haven't practiced for a long time. So you may want to write some extra notes here. And remember this, because we're going to be using this a lot. So this is actually a very important operator in programming. You have to know how modulus works. You have to know and memorize this symbol, and know that it stands for modulus, not percent anymore. We do not use this symbol in programming for percentage, unless it's describing a problem, like in a word problem. But typically in code, always in code, this stands for modulus. All right, what's the last operator? There's one more arithmetic operator, also something you've seen in math before, and it's going to look very similar to multiplication. So multiplication uses 1 asterisk, which is the key above the 8 key, so you have to use shift in order to type an asterisk, but this one has 2 of them, and it's different from multiplication, but similar in nature. This is the exponent operator, also known as using powers. And this is going to work similar to how you would expect, but let's do some examples. This is essentially equivalent to, if you've ever used the caret, sometimes caret is used for exponents, but we are using this double asterisk. The caret is actually a completely different operator. It's actually a bitwise operator, which we'll probably not be using this class, which is why I put it last, but we will talk about these symbols later on in this video. Okay, 2 raised to the 3rd power is 8. What else? 5 raised to the 5th power is, oh wait, that's really big. 5 raised to the third power is 125. 1 raised to any power, the fourth power, is 1. And even anything raised to the 0th power is still 1. So that math rule applies as well. Same as normal. So these are all our arithmetic operators. We're going to use these guys a lot. We're going to be practicing these lots when we do tracking problems. So make sure you get all this down and understand these. And memorize that this operator is exponents, this is for modulus, this is for integer division, and the regular operators. All right, moving on. Assignment operators. So far, we have looked at one assignment operator, the equal sign. This is just regular assignment. So we are taking a value and storing it in memory. So it takes a value and stores it in a variable in memory. Cool. Now, before we get to the other operators, we actually should talk about a new term here before we move on. We'll put it right above this, a new vocab term, which is called an expression. You actually use a similar word in math classes, but an expression is a, let's do an example, I guess, a string of, it is a string of numbers and operators being all used together. So we could have something like this. There we go. We're using a bunch of our operators here. This is an expression. So anytime that you have more than a single number, you typically call it an expression. And the key with expressions is that expressions evaluate or simplify to a single value. That's what an expression is. So for this example, we should be able to simplify this to one value. Just looking at it, well, this is kind of long. We don't know what this is just from looking at it, probably. So let's figure out what this is, and then we're going to talk about ways that we can incorrectly evaluate an expression like this. So let's do it first by doing it manually. Maybe I should label this. Let's see. Incorrect way to evaluate. Ooh. I'm a little bit frozen. Oh, all right. Let's keep going. So incorrect way to evaluate this expression. We'll just copy paste that. And we'll copy paste it again. Okay, so first we do 12, and then we say 34 for 12 plus 22. 34 minus 6 is 28. We're just working our way left to right. This is going to produce an error. So think about what is wrong with what I'm doing here. 3 divided by 2 is going to be 1.5. We drop the 1/2, so it's just 1, and we get 11. Now, something wrong with what we did this, and it wasn't a multiplying or dividing or subtracting error. So think about what that is. All right. And if you realize what the issue is, good job. We have to follow what's called the order of operations. Need to follow the order of operations. So this is the same in math, except we now have some extra operators. So we got to figure out the new acronym, the new order of operations. So in math, we normally call this PEMDAS, which is that you do the all of the parentheses first, then the exponents, then multiplication and division, then addition and subtraction. So multiplication and division share the same precedence. Addition and subtraction share the same precedence. For computer science, the acronym that I like to use is PEMDAS COPS BOPS. All right. We actually might add something to this later, but we're going to start just with this. To show our equivalence groups for which of these operators are in the same precedence, we'll put some little brackets around things before we evaluate. All right, so there's our groups. Let's write them out. So first, maybe we should label it here. We would evaluate all of our parentheses type punctuation. In Python, we use 3 different ones. We have parentheses, we have square brackets, or just brackets, and then we have curly braces. So let me write these down. Parentheses, square brackets, or just brackets. We have curly braces. And all of these are going to be used in Python. They're not going to be used necessarily in an expression, but we still evaluate these first. What else? The E group. The E stands for exponents. Well, we only have one exponent operator, so we would evaluate that next. Then we have modulus, multiplication. Oops. Modulus, multiplication, and division. But you have to remember division has 2 different operators. It is regular division or integer division. And these all have the same precedence. However, if we have something like this, well, I'll do the example first, I guess. If we have something like this, like let's say we have multiple things that are all next to each other, and we're wanting to evaluate this expression. Well, how do we do it? Let's see if we get the same answer depending on how, in what order we even evaluate this expression, because they all have the same precedence. So let's see. For mod 6, if we're going from left to right, let's try. Let's label this actually left to right, and then maybe we'll just do right to left. See if we get the same thing. Do a little copy paste here. For mod 6 is 4, since the left number is smaller than the right number. Then we have 4 divided by 7 for integer division. Well, normally that'd be 0 point something, but we drop the decimals, so we get 0. So we end up with 0 here. I didn't actually check this example, so hopefully we actually, hopefully this works for what I'm trying to show. 7 times 3, if we're going from left to right, is 21. 6 divided by 21 is, well, 0 point something. So we get 4 modulus 0. Uh-oh. That's an error. We can't divide by 0 when we do modulus. So it does matter the order in which you evaluate these things. If we had started with the middle for some reason and gone left or right, we would have also gotten an error either way. But the point is that it does matter. We'll actually get different values based on how we evaluate these if they're next to each other. So the rule is when we're evaluating these different groups of operators, these precedence groups, we always evaluate from left to right. So we'll see an example of this when we start doing some examples with these operators. We'll probably save that for the next video when we're doing tracking problems. So if you want to see an example of how we actually use PEMDAS to evaluate these expressions, we'll be doing that in the video right after this one. The next precedence group is addition and subtraction. I don't think we need to go over these. They're going to work as you think they would. Then our last two groups are two new things, cops and bops. These do stand for something. This is my own acronym. But first we're going to do our conditional operators, which we haven't actually looked at. We're going to look at here, but we've probably seen these before in math, and a lot of them are going to work the same way as you'd expect. We have less than, greater than, less than or equal to, greater than or equal to, is it equal to, or the equivalence operator, and is it not equal to. So all those guys we would evaluate next. And lastly, we have BOPs, which stands for Boolean operators. And these are some of our few operators that are not actually symbols. They're words, which are and, or, and not. We will be looking at these when we look at truth tables and if statements, which will be in some future videos. Oh, that's it. There are some categories here that you'll see are not in this PEMDAS list. The ones that we're not going to talk about yet are the access operators, the string operators, and bitwise operators. They would fall somewhere in this list, but for what we're studying now, we don't need to know those yet. Okay, so there's our new order of operations. So this is our new acronym you should remember. It's mostly the same, so it's not too hard. The main things you have to remember is that modulus now shares precedence with multiplication and division. And now we have two things that we do last. So what we'll end up doing with conditional operators is when we compare expressions, the results of expressions, we do the comparison once everything's evaluated. And then for Boolean operators, we can actually then take that result, which is going to be a Boolean value, and then compare those Boolean values, which we do dead last. Okay, we're going to move on to our assignment operators now. All of that we needed to talk about because for our assignment operators, we're going to use the arithmetic operators. So what do we have? We have plus equals is what we call it. We have minus equals, times equals, oops, and so on. All of these operators here are just taking our arithmetic operators and adding an equal sign after it. So there's nothing like, these aren't like, don't mean something completely different. We're going to be using the arithmetic operators as you know them with all of these. All right, but how do they work? So all of these are actually shortcuts. So I'm going to highlight all these, press tab. These are all shortcuts. So for example, we got our plus equals. Something we could do is we could take a variable like box, set it equal to 4, and let's say on the next line we take box, set it equal to the old value of box and add 3. So after this line here, box would have the value 7. We take the old value box, we add 3 to it, we now have 7, right? That expression evaluates to a single number 7, and then we store it in that variable box. And we replace that value in memory. Programmers at one point decided that this is too much typing, so they made a shortcut using this plus equals. So this last line here is equivalent to box plus equals 3. So this line and this line are the exact same thing. They do the same thing. This is a little bit less typing. This is a little bit more typing. The main thing we have to realize when we do this is that we're going to run into distribution errors if we're not careful with using minus equals and times equals, which both distribute and change values if we don't handle them correctly. So first, let's do an example. Let's say we have box again, it's equal to 4. If we use minus sign, normally we'd be doing something like this. But let's add a few things. Let's say we actually have 4 plus 7. So, wait, no, this doesn't make sense. Boxes 4 is fine. Let's say we actually take our old value of box and we want to subtract 4 plus, no, about 3 plus 5. Sure. Well, if we do this for mathematics, we know that this minus sign distributes. You could also just add this together and get 8 first. But if you did not do that, we would need to distribute that minus sign. It would be 4 minus 3 minus 5, not a plus 5. This doesn't remain as a plus 5. So when we have, our shortcut here, the minus equals, that last line is the same as this. So we drop the parentheses. We don't need the parentheses, but they're actually implied. So when we are looking at this line, this minus sign is going to distribute. And if we had another variable here, we could see that. Let's say we haven't, let's do a new example. Let's say we have 2 variables, A and B. And we say A minus equals, maybe we should have 3 variables. And C is equal to 3. A minus equals B plus C. Okay, it's a little less obvious because it's a little harder to just add together B and C. It's like multiple steps because we have to do substitution. So when we write this line, this is equivalent to A is equal to A minus B plus C. So we're taking that old value, just like we did here, and that minus sign is going to distribute to the expression on the right hand side of the equal sign. So here's our rule, just what I said. Rule: when we use minus equals or times equals, we have to be very careful because there's going to be some important distribution that happens. I guess this is true for division equals too. Yeah. So times equals, divided by equals, integer division equals, modulus equals, exponent equals. Make sure to use parentheses for the expression on the right hand side of the assignment because we need to distribute correctly. And what this really means is that we need to first evaluate the right hand side before using the operator with the old value. Okay, that's a lot. The important thing is that if you're going to distribute, you could do that, or you could just evaluate it to a single value and then you don't need to distribute, right? We could just evaluate this to 8, and then this is box -8, and we're not really distributing the minus sign. We kind of are secretly, but yeah, it's you could do it either way. Okay, for times equals, that's going to work really similar. If we have a times equals b plus c, that's the same as saying a is equal to a times b plus c. I will write out the example here for these just so we're clear for at least a few of these. So if we say times equals, this is the same as saying a times b plus c. And we know that the times distributes. We would have a times b and also plus c times, or a times c. Right? I'll write it out. In math, we would write AB like this. In computer science, we cannot write this. The compiler would not know that that is 2 variables multiplied. It would think it's 1 variable. So we have to just write it like this when we evaluate that distribution. Division is going to work kind of similarly. I guess we'll write this out as well. This is just a math thing. Whoops. Let me paste it here. When we use division equals, well, this is the same as this, but division doesn't work like this with parentheses, right? We can't just say that this is the same as a divided by b and a divided by c. That is not correct. That is not mathematically correct. Hopefully you know that from your math class. If you don't know this, then you need to know this, or else you're going to be doing poorly in your math class. So for this kind of thing, the value is going to the correct value is going to be if we first evaluate b plus c to a single value, and then we take a divided by whatever that is. So we can't do this last line. We first have to figure out that b plus c is 10, a is 5, so we're going to get 0.5. If we did it the other way, well, I guess we'll substitute here and just show all of this. So this is what we did. We said this is 5 divided by 10, and then this becomes 0.5. Here's the incorrect way. Incorrectly, we could take this and say that, and then do this. And then when we substitute, we have 5 divided by 7 plus 5 divided by 3. Is this going to be equal to 0.5? No, this is already greater than 0.5. This is going to be 0.7 something. Let's see, 0.71, do some long division in the head, 4, 2, and so on, plus 5 divided by 3. This is greater than 1, 1.6. Is it 1.66? Yeah. And that continues as well, 1.6666, what's 1 2/3. So when we add this together, we're going to get some a value like 2 point something, 2.3-ish. Yeah, 2.37 is wildly different than 0.5, right? So yeah, we have to be careful of that. Okay, you can see that the parentheses are really important. I'm not going to do examples for all these, this video is already kind of long, so we'll move on. What about our conditional operators? Our conditional operators, we listed them up here. So let's write them out again. This is greater than symbol. I always get it mixed up if this is called the greater than or less than symbol. But I think this is greater than. This would be less than. Totally could be wrong here. This is greater than or equal to. We got less than or equal to. And then we got some new ones. This is the equivalence operator. And here we have the non-equivalence operator. This is also the same as simply not equal to. And then this is the same as equal to as a check for equivalence. So what do I mean by this? Essentially all of these, when we use these operators, we need two or more values or expressions, and the expressions or values are compared, and we get a result of what? Well, we get a result of true or false, which we call Boolean. This is one of our data types, true or false. So, for example, if we say, is 4 greater than 7, this is false. So this entire thing here, this conditional expression, evaluates to false. We could have something like this, is 5 less than 10? Well, that's true. Is 5 less than 5? False. That is not true. Just be careful of that. Less than is going to work really similarly. Greater than is going to work how you'd expect it. Same with less than. For the equivalence operators, these are actually quite simple. If we have something like this, is 3 equal to 3? Well, the result is true. And if we have a number compared to something that is not that value, is 3 equal to minus 7? No, false. Okay. Lastly, we have not equal to, and this is going to be very similar. Is 3 not equal to 5? True. 3 is not equal to 5. Is 3 not equal to 3? False. They are equal. So we'll be using these when, in particular, when we work with if statements. All right. For these next sections, we're going to go through these much quicker because these are all going to be used much further in the future, and I don't want to be repeating myself in a future video. So this next section is really just to talk about what other symbols are being used, and we'll give them names, but we're not going to do examples because, yeah, we don't got time for that. So Boolean operators, what do we got? We have and. What do we call this? This is really just and. Trying to think if there's a different name. Not really. This is the and operator, or very similar. And then not, we call this negation operator. And that's it. That's it for the Boolean operators. The containment operators, we've already talked about these, I believe, in terms of precedence. These are also going to be used for a few things. And they're going to be these same sets of punctuation are also used as the collection operators. But when we're talking about these, we are defining the scope of something. What is scope? We need to define this value, this vocabulary. Scope, we're going to use this word a lot. There's a number of synonyms also, so you have to be careful with that. We also call scope is the same thing as the container. Another synonym is the I always have trouble with these synonyms. Every time. I don't know. We'll have to look these up. But there's two others actually. But what are these? What is the scope? This is going to be best done with an example. When we make a variable, we said in class that we kind of think of it like a box. We could put something into it, we can take it out, we can change that value, we can put it back into the box, and this is kind of how memory works. We're always accessing memory, changing something about the memory, putting it back in memory. Well, when we're going through our script, like when we looked at, let's see, this last, when we talked about variables in the last video, we just go line by line, right? It's all straightforward. So you can think of this large script here, this big page, as a single box, but it's an ordered box. We're going through one thing at a time. Sometimes you're gonna run into a situation where when you reach a line, you want to do kind of an organized set of different instructions, which we call functions most often. And we'll put those in a separate box. So it's like we're putting a box in a box. So whenever we do that, we have defined a new scope. And a scope is really just another box. So scope is a box in a box, but if we needed to define it, this is the set of program lines belonging to a single structure. Maybe we should say that it's ordered as well. We'll worry more about this vocab in the future, so we'll come back to it. Let's move on. Collection operators. We will use these in the second half of the semester. The square brackets are used for defining lists. We use the curly braces to define something called sets. We use the parentheses to define something called tuples. And we use a set of curly braces and a colon to define something called a dictionary. Okay, we'll look at these in the future. Identity operators, we have the is operator, another operator that's just a word. Okay, it's autocorrecting. Don't want to do that. Ooh, what's the name for this? I think it's just the is operator. And the is not operator. We'll use these when comparing objects. The membership operators, another word, in. I think this is actually called the containment operator. And the not in. I don't know if this has a name. We'll just leave it as the not in operator. Okay, access operators. We do use the period for accessing things when we start talking about objects In classes, we will talk about this, but for now, we just call this the accessor operator. Moving on, there's only one access operator. Don't quote me on that. There's some other niche things that you might call access operators, but the interpreter operators. We've used some of these so far. We're including comments in this list. So the number sign is the single line comment. We have the triple quotes. I can't actually write the triple quotes or else I'll be ending my multi-line comment. So I'm just going to write triple quotes. This is what defines a multi-line comment. Same thing with triple apostrophes. I'll just write that down. We also have the @ symbol. We will not be using this in this class, but this is for working with the interpreter to kind of flag something as a particular type of function or class. So we just call this the flag operator. Most people would not call this an operator, but we just want to look at all the symbols today for fun. So, and it's also useful because if you see this somewhere else, you want to know what these things are for. At least have a way to access them and know that they're doing something. For string operators, we actually are going to reuse our plus sign. We use this for something called concatenation. We will be talking about this soon. What else? We use the backslash. So instead of division, when working with strings, we're often using this with paths. So I'm going to say use for file paths, where files are located. We also are going to use the backslash. So, sorry, forward slash. The forward slash is normally going to use one of them. This is called the, well, normally you would use one. This is called the escape key. The escape, is it key? The escape key or operator. So this is used for escaping certain characters in strings. What do I mean by this? Let's say you have a string like John said hello. When strings are defined by these quotes, right? But what if you have a quote in a quote? What do? Well, normally this would end the first string, so this would be a string, and then your compiler would think that this word is part of the expression, and it would get confused because it's touching the string literal, and well, that's an issue, so you get an error. So in order to keep this quotation as part of the string and for it to not end the string, use the escape key. So if you did this, the little slash is telling your compiler that this is actually belonging to the string and it's not actually ending the string. So that's one example of when that is used. We'll also use these for very important characters like this. This is the line break character. So if you ever want to put a new line within a string, you would use one of these special characters. And there's other special characters that do things. But we'll have a whole section, a whole units on strings. So we will return to these in the future. Lastly, this is something we're not even going to cover in this class, but I still want to put it here because it's good to know what these symbols are and that they're actually used for something. And if you do use them in your code, here's another reason we want to know these. If you do use these, they might actually not break your program, and they might actually do something completely unexpected, which might be difficult to fix in the future. So let's look these up. I don't trust myself. I'm going to remember these correctly, but here they are. So we're going to use these double alligator bracket or alligator punctuation. We'll actually use the and symbol. We'll use something called the pipe. We'll use the tilde looking key above the tab key. And we'll use something called the caret. Another reason we want to be careful with these is that if you accidentally put two of these, we're no longer doing it, using it as a conditional operator. We are now shifting the bits of the data, which is going to be something different than multiplication, different than addition, and other things. This is also important to know because in Java and in other programming languages, these symbols are used for Boolean operators, but here they're used for bitwise operators. So if you're used to any other languages, you have to be careful because these are not used for what they are used in other languages. And then this one's also important to know because in mathematics, sometimes you might see this, like if we're typing, to represent exponents. But in Python, you cannot use this for exponents. This is doing something very specific called a bitwise exclusive OR. We won't even get into this. This is something you might study in college, in a programming course, or if you become an electrical engineer or a computer engineer, you might care more about these operators. So we'll just write them down. Just know they exist. Just know that they do something. And we'll ignore them for the rest of our class. So we got these three. I have used these before as I've programmed. They do have some uses that are practical, but many of these I've really only needed for one or two applications ever. So it's pretty rare that you need these in modern programming. If you were really concerned about memory usage, or if you are working in compression or other spaces, you might use these more often. So let's see, this was the one of the shifts. Shifted to the left. I guess this is the bitwise left shift. So this is the bitwise right shift. We have the bitwise and bitwise OR. Bitwise OR. We have the complement. And the bitwise exclusive OR. Okay. Cool. So we've got pretty much every symbol or punctuation you'll see in Python in this list. Is it possible I'm missing one? Certainly possible. Certainly possible. So we'll get that to that when we need to. In the next video, we are going to practice using these operators, specifically the arithmetic and assignment operators, and working to evaluate these correctly.